So today I am going to explain you about the galvanic cell. This is a topic that I have chosen for the video based experiential learning for the chemistry subject. So before understanding exactly what galvanic cell is, we need to understand some other terms and we proceed as follows. So first we need to understand what is a half cell. So basically half cell means the metal dipped in its metal salt solution, the metal dipped in its metal salt solution. For example, if we take the metal as zinc, then the metal salt solution of the zinc is zinc sulfate. So the zinc rod, this is the zinc metal rod, and it is dipped in the zinc sulfate solution. This is zinc sulfate solution, and the concentration of the zinc sulfate solution is 1 molar. We are taking a standard case. In standard case the concentration is 1 molar. In non-standard case we have different concentration. For that we use Nernst equation, but we are not talking about all those things here. In standard case the concentration of the zinc sulfate solution is 1 molar. The same another example, if we take the copper as the solid, then the salt solution is the copper sulfate. This is the copper sulfate solution. The metal rod is dipped in it, and here again the concentration of the copper sulfate solution is 1 molar. So this is the zinc half cell and this is the copper half cell. Now electrode potential. Electrode potential means the potential between the metal rod and the ion present in the solution. The potential difference between the metal rod and the ion present in the solution is the electrode potential. We have two types of electrode potential, that is the reduction potential and the oxidation potential. So first we will see, this is here the copper ion is accepting in this reaction, the copper ion is accepting the electron, and it is getting converted into the copper solid. So here what is happening, this is the gain of electron, hence this is reduction. So this thing gives us the standard reduction potential. So the standard reduction potential of the copper is plus 0.34 volts. This value is taken from the NCERT book. These are the standard values. For oxidation, see, in oxidation means the loss of the electron. Here the copper solid gets converted into copper ion and it is releases the 2 electron. So this is oxidation reaction, and the standard oxidation potential of the copper is minus 0.34 volts. So this is the relationship between them. So if you have reduction potential and you want the oxidation potential, just minus it. So minus any one and get the other one. Simple rule. Now this is what galvanic cell is, cell combination. For galvanic cell we take zinc and the copper half cells. So in this, the half cell which has less reduction potential, that thing behaves as the LHS or the anode of the half cell, and the cell which has more reduction potential behaves as the RHS or the cathode of the reaction. So in this case zinc has less reduction potential and the copper has more reduction potential. As we can see, the standard reduction potential of the copper is minus 0.76 volt and the standard reduction potential of the copper is plus 0.34 volt. So the reduction potential of the copper is high, hence the copper will behave as the RHS. So the reaction that takes place at the anode is zinc. So zinc has less reduction potential but more oxidation potential. Less reduction potential and more oxidation potential. So hence it has tendency to do the oxidation reaction, to get oxidized. So here the zinc solid gets converted into the zinc ion and releases 2 electrons. So this is the oxidation reaction that is happening. So what happens is the zinc solid is getting converted into the zinc ion. So with time the weight of the metal rod will decrease and the ions zinc plus ion in this solution will increase. And so now what's happening is, now in this reaction you can see this electron is moving away, it's getting released. So the polarity of the anode is negative. For electrolysis we have different case. Here this is different. Here the polarity of the anode is negative, because as the electron is moving away, negative and negative repel, hence the electrons are moving away, so the polarity is negative. Now the reaction that takes place at the cathode. So at cathode we have copper has more reduction potential, hence it will undergo the reduction reaction. So here the copper ion is accepting the electron reduction and it is getting converted into the copper solid. So what happens with time is the concentration of the copper copper ion in the solution will decrease and the weight of the copper rod will increase. So now here what's happening is the coppers are like the electrons are coming like electrons are coming to it, hence it has a positive polarity, because we see electrons are coming in the solution is accepting the electron and getting converted into the copper solid, hence the polarity is positive, and this is the cathode. So in here we have anode with negative polarity and cathode with positive polarity. Don't get confused with the case of the electrolysis, here the polarities are different. Now in the what is happening in the external circuit, see what is happening like this. So electrons are moving from the zinc to the copper, electrons are moving from anode to cathode, hence the current flows from cathode to anode. This is the I direction. The current will flow from cathode to anode. This is the flow of current, and this is basically, this is salt bridge, this is potassium chloride or ammonium chloride. This basically maintains the neutrality of the cell. Thank you. I hope the galvanic cell is clear to you. I have explained the all the details. Just one more thing, like this is the net cell reaction that takes place. The zinc is getting converted into the zinc ion, and the copper ion is getting converted into the copper solid, and the standard cell potential is given by oxidation of the LHS. The zinc that is undergoing the oxidation, it has oxidation potential of 0.76 volt. These are the standard values, and these values were also mentioned above, and these are taken from the NCERT book. And this standard reduction potential, reduction of the RHS, the copper half cell, that is 0.34 volt, and this is the 1.1 volt, the standard potential of the galvanic cell. So this is one more thing which is very important, that is the change in the free energy. So change in the free energy basically gives us the useful potential. Here the case is standard, but as I told in the beginning of the video, not every time the concentration of the salt is 1 molar. We have different kinds of concentration. So and with the time the concentration decreases and the potential of the cell will also decrease. So the measure of the useful potential is calculated by the change in the free energy. This is free energy, and this is the formula for it. Thank you.